Okay, so I'm going to make a start. So, has anyone downloaded the lecture slides for this week already? Okay, if you have, be aware that this Thursday's lecture has completely changed compared to what was up earlier on the week. So if you've already downloaded the slides, download them again. So I'm going to begin very quickly just reminding you that Assignment 1 is due this Sunday. Okay, a couple of things to be aware of. There's a late penalty of 20% per day off your mark. This is different from other courses, so that comes off the maximum mark. The late penalty is off your individual mark. If you have issues, email course staff before Friday. We don't have to reply to emails over the weekend. If you're submitting via Give using a web interface, be aware that that's not supported. So the way in which we've told you to submit is using SSH. Okay? If you submit via Give, and if you submit via SSH, but particularly if you submit via the Give web interface, please make sure that you check your submission has been correctly received. Okay, so when you submit, you should see the word submission accepted down the bottom of the submission. Oops. If you don't, it hasn't properly been received. So a lot of you guys will know this already, but to check your submission, type the command 6771 class run check assignment 1, and it will show you when you've submitted and your most recent submission. Okay? Make sure you check that your submission's been received, particularly if you're using the web interface. If you go to submit and you have a compile error, step 1, fix it. Step 2, if you can't fix it, the deadline's coming up, okay, and you just don't know what's going on, okay, you might get an error message like this when we go and submit, where you go to submit. It says, compiling your submission, oops, there's an error message. You should fix these, okay, but should I continue with the submission? Okay? Your choice at this point, yes or no, okay, but it's better to submit something that even doesn't compile than to submit nothing at all, okay? So if you can't submit or you can't get it to compile, still push on with submission. Same with dry run errors. If your code compiles but doesn't match dry run, you might get an error message like this. You have failed this test. You can submit now if you wish, but you should fix your program, okay? Should I continue with the submission, yes or no? Your call, okay? But if it's Sunday night, make sure that you submit, okay? And hopefully on Sunday night you're not looking like this guy, okay? Okay, so I received an email from a student, I think it was Monday, I received an email from a student saying, why can we not use namespace standard? And I've already told you in lectures twice, do not use using namespace standard. It's bad practice. You will see using namespace standard everywhere, and lots of code examples, lots of textbooks, lots of everywhere, okay? It is actually really bad practice. And the key reason I've already pointed out to you is it pollutes the global namespace, okay? And what this means, that if you have a function in the standard namespace that you're using, and that function changes, and then clashes with a function prototype in your code will no longer compile, even though you haven't changed it, even though the standard namespace is being thing has changed, okay? So using namespace standard opens you up to problems that might cause your code not to compile, even though you haven't changed your own code. And this is becoming a big issue as everyone moves towards C++11, C++14, okay? Whereas a lot of old code had these two lines at the top of all the files, using namespace standard and using namespace boost. And boost is an extra library that provides a lot of extra C++ stuff. And in C++11, they moved a lot of it using namespace boost stuff into standard. And so lots of old code that had using namespace standard and using namespace boost now doesn't compile. Okay? So there's a Stack Overflow answer. It gives you a whole ton of points about why it's bad practice and all the things that can go wrong. Okay? But this is the third time I've said it. Do not do it. Okay? If you use namespace standard in your assignments, you will lose marks for it. Okay? Okay, so moving on, this is also, I suppose, this is the start of where today's lecture actually starts from. Okay? We're going to spend some time talking about uniform initialization. And this is something that wasn't in the slides earlier this week, okay, but something I came across when I was building for slides actually all the way up for week 9. And I think it's important to tell you guys about this now. So on Monday, we looked at how to construct objects. And also last week, we looked at how to initialize objects, okay? And so up on the screen here, I have a bit of a problem for you guys to solve. I've got 2 objects. I've got a timer object, okay, it's a struct timer, has a constructor, doesn't do anything. I have a timekeeper object, okay, also has a constructor, okay, and the constructor for this one takes in a timer object, and it's also got a member function that prints out something, okay, prints out that's inside somewhere. I then go into main, and I create a timekeeper object. Well, at least I think I create a timekeeper object, okay? And then I say timekeeper.printtest, okay? Can anyone see any problem with this code? Or can anyone answer the question what's below? On line 11, what is timekeeper? Okay? Is timekeeper an object? Or is it a function prototype that returns timekeeper object? What do people expect it to be? So it's line 11 over here. Timekeeper takes in a timer object that's been constructed at that point. That's the intention of that line. Okay, do people understand what the intention of that line is? Yep. So what do people think this actually is? Who thinks it should be, okay, maybe it's not, but who thinks it should be a timekeeper object? Okay, most of you. Who thinks it should be a function prototype? Anybody? Okay, it kind of doesn't make sense that it should be a function prototype because it's inside main, okay? The really annoying thing at this point is the compiler thinks it's a function prototype, and then the code doesn't compile not because of that line 11, but because of line 12. And so it thinks it's a function prototype, and then on line 12, when you ask that thing to print test, it going, well, it's not a class. Okay? So if we look very carefully, this is line 11 here, okay? There's no apparent bug on this line. You have intended to create a timekeeper object correctly using the constructor, okay? There's nothing tricky about this code, and it just simply doesn't work, okay? So this is called a vexing parse. What you're expecting it to do and what the compiler's doing is 2 different things. Okay? So the question is, how do we fix this? I'm not going to tell you for now. Okay, I'm going to tell you in a couple of slides' time. I'm going to give you a different example first of all. Example 2. I have a function, void f takes in a double. I then say int I, okay, so I want to create an integer I, and I want to cast that double to an int, and initialize that I with the double correctly casted to an int. I'm trying to do the right thing, I'm trying to do the cast here, okay, and then I'm going to print it out. Same question as before. What is I? Is it an int containing a double, either cast or constructed to be an int? Or is it a function prototype that takes an int and returns an int? What do people expect it to be? So line 2, what do you expect line 2 to be? Do you expect it to be an int, or do you expect it to be a function prototype? You expect it to be an int. Who expects it to be an int? Most people. Who expects it to be a function prototype? Who doesn't know? Sorry? After what you saw last time, yeah, you got to say it's a function prototype. But what do you expect it to be? You expect it to be an int. It's a function prototype. Okay? If you did int I equals, and you did that, that would be fine, but that's not the question. Okay? Okay? The question is, at this point, you're trying to use the constructor for an int, and you're trying to correctly cast for double down to an int. You're trying to do the right thing. Okay? And it doesn't compile. And again, it doesn't not compile on line 2. It doesn't compile when you get to line 3. And actually, the only reason why this one doesn't compile is because we've got warning for so wall and where on. So those are flags saying give me all warnings, convert all warnings to errors. The only reason why it doesn't compile. If I didn't have the flags wall and where on at this point, this would compile and run and do something you do not expect it to do. Okay? What it would do is every time it printed out I, it would print out true according to that warning, okay, which would actually be a 0 or 1. So that I value you're trying to print out is always just going to print out, I think it's going to always print out 1 if it actually did compile. Okay? So again, we ask the question of how do we fix this? Okay? Anyone got any idea about how we fix this problem? Yes, your example of we could change it to int I equals, okay, but that's not the answer, okay? But how might we fix it? Anyone got any idea? Okay. Is everyone following what we're trying to do up until this point and how it's going wrong? Or maybe not how it's going wrong, but everyone's following what we should be trying to do at this point. Yep. Okay, so in week 2, we had this slide about initialization. And about 6 different ways to be able to initialize an int. Okay? Line 2, we've got int I1, curly braces 1. Line 2, we've got I2 equals curly braces 1. On line 4, I3 is equal to 1, which is how you would have seen it back in the C days. Line 5, int I4, brackets 1. That's to us using a constructor. And this doesn't just apply to ints, this applies to any types that you're constructing. Line 7 you might not have seen, but okay, here's J1, gets a squiggly brace like that, where that's the default values being used. And then in line 8, we've got J2 equals int squiggly braces. Okay, so that line 8, we'll talk about this later on today, but that's constructing a temporary int, which is then potentially being copied into J2. Now, the optimizer might do some other stuff, okay, but that line 8 is actually creating 2 ints. It's creating int J2, it's creating a temporary int, and that temporary int is being copied into J2, okay? And the point of this from week 2 is there's a lot of different ways to initialize objects, okay? And some of them are backwards compatible because of C, okay? And this is about to become a really good point where the standard has changed for the better, but you're about to get very confused because everything you think you know about constructing objects is about to change, okay? And hopefully change for the better, but you're about to get a whole lot of new syntax. So the way in which we fix this, okay? Before I tell you how to fix this, the problem is C++ confuses type construction with function calls and function declarations, okay, as we've seen on those couple of slides previously. And basically a quote here is, if it can possibly be interpreted as a function prototype, it will be. If your code can possibly be interpreted as a function prototype, it will be. Okay? And as you saw in those 2 examples earlier, you don't get for error messages at that point. You get for error messages later on when you try to go do something. It goes, oh, I'm not a function, I'm not an object, okay? So the solution to this problem is rather than using these rounded brackets to construct objects, you should be using braces, because the braces cannot be confused for function calls. Okay? So the solution to our problem with our timekeeper one is to change those braces like that to squiggly braces like that. Okay? Because this cannot be confused with a function prototype. Okay, so that's the quick, dirty solution. It's not dirty, but quick, correct solution under the new C++ 11 standard. Okay? So ideally from this point on, you should be constructing all your objects this way. Okay? Now I'm going to be the first guilty party here and tell you I'm going to mess it up all the time. Okay? Because I'm learning this myself. Okay? Everything you know is wrong is the short version. Okay? This is how you should be doing it from this point onwards. there's some links on the bottom of that page there. Okay, this is called uniform initialization. Go away, have a read about it. Also look about how to do for most vexing paths. Okay, because you will potentially run into these problems. Now, what I'm going to return to is what about our problem with int? Okay, so we're trying to do the right thing. We're trying to cast a double to an int, and it didn't really work. Okay, so according to what I've just told you, is this now a solution to this problem? Who thinks it's a solution to the problem? Okay, who doesn't think it's a solution to the problem? Why not? Because I'm making a point of it. Okay, this is a solution to the problem, only now we've got another problem. Okay, so we go do that, and our error message changes. Okay, so we got rid of our error message about it being confused to being a function prototype, and now it says we are narrowing. We cannot narrow the conversion of a double to an int using this approach. So before, that previous slide, if it didn't get interpreted as a function prototype, it would be doing the right thing. We are casting that double down to an int. Okay, and that's what we're intending to do. But this new approach for how we construct objects is now saying you can't do that. Okay? Again, if you remember all the way back to week 1 when we were talking about casting and we're showing you all the silly things that can happen with casting without any warnings at all, here's the good news. The good news is the compiler is now correctly giving you a warning. Okay? Now, I'm going to stress the point, it's giving you a warning because we're compiling with Wera, which turns all warnings into errors. It won't compile for us, okay? But we'll always get a warning during this approach, okay? So it's actually a good thing. It's telling us that we're doing something dumb, okay? So looking at this, in C-style code, we can initialize and we can cast and we can lose precision without any warnings, okay? So int pi is equal to 3.14. It compiles fine. Int pi is equal to int 3.14. Compiles fine. That's C-style, okay? Trying to say int pi equals squiggly braces 3.14 will always warn, and if you're using Wera, which we are, it won't compile. Okay? Because it narrows. It's changing the definition of what this thing is. Okay? So to correctly narrow these values, we need to use a static cast, again, which you would have seen in week 1. Okay? So the point of going through all this, okay, is to basically bring together, at this point, what we've looked at over the last couple of weeks in terms of we've looked at constructing objects, we've looked at casting objects, we've looked at there's many different ways of doing things, okay? But these are some of the problems that you can start to fall into, okay? And so what we should be doing is always trying to write C++11 compliant code. There is lots of old coding styles that you'll see, okay? You Google something, how to do it on Stack Overflow. Any of those answers before, for argument's sake, 2011, 2012, okay, may not be correct for the updated standard, okay? And I'm going to make, for the rest of the semester, these mistakes as well, okay? But you should always be trying to do the new style, okay? Are people clear on that? Are people clear about where those problems happen with the vexing parsers and how we fix them, okay? Definitely go read up on some of this stuff, okay, because you're likely to bump into it. Okay, so now we're going to pick up on where we left off on Monday. So on Monday we talked about objects, and we talked about how to construct objects. Okay? For the rest of today, and also then for the start of next week, we're going to be looking at how we copy and how we move objects around. And so we're going to be looking at a thing called the Big Five. And the Big Five is how do we construct a copy of something? How do we, when we assign something, we do the copy, and so it's going to be a discussion about the difference between constructing an object and assigning an object. We're going to look at how you destroy an object, how you move an object, and how you do what's called move assignment. And we're also going to end up looking at L value and R value references, okay? So again, in week 1, we taught you about references. The references that we've taught you about until this point has been L value references. We're going to now teach you about R value references probably on Monday. Okay, so if you have forgotten what L values and R values are, again, go look it up. Okay, But an L value, for short version of it, is it belongs on the left-hand side. Okay, it's more complex than that, but for L value, it belongs on the left-hand side, and is normally associated with a piece of memory. For R value, normally belongs on the right-hand side, and it's normally associated with a value at a particular memory address. Okay, and so when we talk about references, we're either referencing a piece of memory, or we can now actually be referencing a particular value, depending if it's an L value or an R value. If you've forgotten about this stuff or confused about this stuff, again, go look it up. Okay? So, through constructors, we can build objects. Okay? Creation, construction is a key event, of course, in the lifetime of an object. Okay? It's where the object begins. Okay? But other key events are copying, moving, assignment, destruction. Okay? And we talk about these things as copy control. And we should know the difference between them. Okay? And so for constructors, for copy and move constructors, define what happens when an object is instantiated in memory from another object of the same type. Okay? So up on the right-hand side here, on Monday, we looked at how we just did some constructors. Okay? And so the first constructor up on the left-hand side here, so right-hand side, says sales data object, okay, is constructed from a standard string. This is not a copy or move constructor. This is just a normal constructor. Okay? Our copy constructor, okay, which is actually commented out at the moment, but our copy constructor down here says sales data const sales data reference. Our copy constructor is an object, so it's a constructor that takes in another object of exactly the same type. Okay? I'm going to come back and explain what this operator equals thing is down here, but just for the meantime, if you want to know it's a copy assignment operator, we're going to spend some time talking about that later on. A move constructor, the difference between a copy constructor and a move constructor in terms of the function prototypes is this. One's got a single and, one's got a double and. They mean completely different things. One is a copy constructor, one is a move constructor. Move constructors we're going to talk about on Monday. Okay? But these ampersands start to mean quite important things. Okay? So let's begin by talking about, first of all, destructor. So a destructor is a function that's only ever called when an object's destroyed. You should not explicitly call it. It's called by the compiler when things go out of scope. Okay? But on the left-hand side, you can see up here, it looks like the default constructor. The difference is it's just got this tilde at the top of it. Okay? The destructor is unique. It can't be overloaded. Okay? So it always looks like that. Tilde, whatever the class name is, open and close parentheses. Okay? There's no list of parameters that goes into there. Okay? When the destructor is called, two things happen. One, whatever is written inside the function body goes and happens. Okay, and that's up to you to code. The second thing that happens is the members of that class, okay, so our class that we constructed on Monday has a string, has an unsigned int, has a double, okay, has another unsigned int down here, okay. They're destroyed by calling for destructors on those objects, okay, in reverse declaration order. What that means is when we're talking about for constructors on Monday, we said that we had to initialize the string first, and then the unsigned int, and then the double, and then that second unsigned int. Now we do that in reverse. Okay? So the destructor takes things apart in reverse order. Okay? Members of STL container types, okay, like vectors and stuff like that, are automatically destroyed by their own custom-made destructors. Okay? And smart pointers are also automatically destroyed. We're going to talk about smart pointers in about 2 or 3 weeks' time. Okay? But if we've manually created some memory, okay, we're going to use new, but if you're in C land, you might have used malloc. Okay? Our destructor has to go clean up that memory. If our destructor doesn't clean up that memory, we have memory leaks. Okay? And again, next week and the week after, we'll be looking at some of these issues. If we don't write our own destructor, the compiler goes and builds one for us. And it can be wrong. Okay? If we have a class, okay, so here's class A, it has some private data. Okay? And we haven't written a destructor for this. For automatic destructor, it looks like this. Tilde A, open close braces, no except. I'll explain what no except is again next week, but for short version of it, it means that it doesn't throw in exceptions, and it doesn't do anything, okay? And so, the generated destructor here doesn't do anything at this point, but then after this is executed, x1, x2 through to xn is destroyed in reverse order by calling their destructors. Okay, so xn gets destructed first, all the way up to x2 gets destructed second to last, and x1 is the last thing destructed. And so for our sales data class, if we don't write for destructor ourselves, it looks like that. Okay? Now, there's a point on this saying there's no need to provide a destructor for a class if the data members are non-pointer related. Okay? So if you're not doing anything with dynamic memory, generally you don't need to provide your own destructor because it's not going to do anything. In next week's tutorial, I'm actually going to give you an example where you do need to still provide for destructor. Okay? But generally, if you're not doing anything with dynamic memory, okay, you don't need to do for destructor. Okay? Which is actually, when we talk about assignment 2, you'll see the note on assignment 2 saying you may or may not need to include the destructor depending on how you've actually written assignment 2. Okay? So when's the destructor called? Variables are destroyed when they go out of scope. So when they leave local scope or global scope or function scope or class scope, when they go out of scope, they're destroyed. Okay? Members of an object, okay, so e.g. I've got my object, my sales data object here. It's got a string and some ints and some doubles in it, okay? They get destroyed when the object gets destroyed, that encapsulates them, okay? Elements inside an STL container are destroyed when the library of a container goes out of scope, okay? So if I have an array of ints, and if I have a vector of ints, and the vector of ints goes out of scope, all the ints inside that vector get destroyed. Let's see if you're paying attention. If I have a vector of pointers to ints, and the vector goes out of scope, what gets destroyed? All the pointers. What about all the ints that the pointers are pointing to? They don't get destroyed. You've got a memory leak. Okay? So, if an STL container goes out of scope, the things that it holds goes out of scope and gets destroyed as well. But if, in the case of those things being pointers, what they're pointing to doesn't get destroyed. Okay? This is why you'd need to use a destructor. Dynamically allocated objects are destroyed when the delete operator is applied to a pointer on the object, okay? We'll explain what this means again in the next couple of slides and also the next coming weeks, okay? But that's the same as, again, if you'll see you've got malloc and free, okay? You have to clean up the memory after you. If they're dynamically allocated, when you use this thing called delete, it calls for destructor. Temporary objects are destroyed at the end of the full expression in which the temporary object was created, okay? So there's ways in which I can create temporary objects. You saw some of them on the uniform initialization slides to do with the two ints and then the ints being assigned. The temporary object gets destroyed once it's at the end of the expression. Okay? And the short version is the destructor is called whenever something goes out of scope. Okay? So here's an example. Okay, it's probably the first time you've seen new and delete in this course. Okay, I'm assuming most people know what new and delete is. Okay, if you don't, short version, new goes and creates an object, delete deletes an object. So let's say we have a sales data object here. Okay. The sales data object D1, that's fine. A standard vector of sales data, that's fine. And int I, okay? And this is inside a scope and brace. The end of this brace, when these things go out of scope, all the destructors for those three objects get called, okay? D1, which is a sales data object, and V, which is a vector, get destroyed. The I doesn't have its destructor called, because I is a built-in type, okay? And if we're in Java, we call it a primitive type, okay? And so nothing happens to I, okay? So the destructor doesn't get called an I because it doesn't really have a destructor, okay? But just be aware, basically, all three of those things go out of scope and get destroyed in some manner. Okay? But this is the point about a pointer, no pun intended. I have a pointer to a sales data object, okay, and I construct that sales data object by calling new sales data. Okay? Here's the first bit that I could change with this uniform initialization. Those braces there could be replaced with squiggly braces. Okay? Sales data Q, okay, I've got a second pointer equals new sales data. Delete P, what that's really saying is delete star P. Delete for dereference of P. Okay? So the destructor for dereference of P, okay, so the destructor for sales data is called, and the memory at that point is then freed. If we then go out of scope at this point, okay, if we then go out of scope, the pointers P and Q are destroyed. Okay? But what we haven't done at this point is we haven't destroyed what Q was pointing to. So we've destroyed what P was pointing to, but we haven't destroyed what Q was pointing to. We've got a memory leak. Okay? So if you create any dynamic memory on the heap, you have to clean it up after yourself. Okay? A really important point to note here, okay, and this again, I'll be writing for exams, so this is in your exam. Okay? The top set of stuff are stacked-based or named-based objects, okay? They are destroyed automatically. The bottom set of stuff are what's called unnamed objects. Okay, so wherever you see the thing that says new, it's an unnamed object. Okay, and the unnamed object goes over a heap. The lifetime of a heap object is the entire program execution, unless you delete it. Okay, unless you delete something, that thing exists for the entire lifetime of the program. The really bad thing at this point is because we've lost the named object, we've lost the pointer, which is referencing that unnamed object, being the thing we constructed with the new. Okay? Because we've lost the pointer to that piece of memory has leaked. And even though it's going to exist for the lifetime of program execution, unless you do a whole ton of really deep hackery with the memory, you're never going to go and find that object again. Okay? So it's really important when you're dealing with dynamic memory to keep track of where things are and to know when you've constructed something, when you've deleted something, when you need to delete something, okay? Because another problem we'll run into is when we then try to access something that has been deleted, or when we try to delete the same thing twice, okay? Again, we'll talk about that in about 2 weeks to 3 weeks' time, okay? So it's lots to talk about on dynamic memory, okay? But it's really important in terms of these destructors here is to know when the destructors have been called, when you need to destroy an object. It's really important to know that, okay? And we're going to come back to this over the next few weeks, okay? So let's talk about copy construction, okay? Let's go back to the constructors, okay? So a copy constructor looks like, on the left-hand side up there, it looks like a constructor that's got the name of the class and it takes in another object of that same class, okay? So the thing it needs is a reference to the same type, and normally it's a const reference, okay? Normally it's a const reference. It's not structured, but normally it's a const reference. Okay? And what you should do is you should copy across the data. That's the whole point of the copy constructor. Anything that can't be copied should be default initialized to whatever the default initialization for those things are. And what I mean by that is, say your copy constructor didn't want to copy the name of a book, it only wanted to copy for prices and the number of units sold. You would default initialize that name of a book to something else, okay? But that's generally bad practice. The copy constructor should copy the entire object or as much of the whole object that can be copied, okay? It's really bad form to go and define your copy constructor to be something just arbitrary, that's just bizarre or stupid or just dumb. Copy constructor should copy, okay? Now a copy constructor is used to initialize an object from another object. Okay, so there's 5 lines of code down the bottom there, and all of these things are going to be using a copy constructor. When we say type A, lowercase a, is equal to other, that is a copy constructor that's being called at that point. This other thing is being copied into A. When we call or pass by value, not by reference, we call or pass by value, say we've got a function called f and we're passing in other, the copy constructor is being called. This thing's being copied. Okay? When we return something, return by value, it's going to be copy constructed. When we catch, okay, we haven't talked about try and catch yet, but when we catch by value, the copy constructor is going to be called. Okay? When we create an array of objects, or a list, or a vector, or something like that, when we create a vector, a list, whatever it is, some sort of container of objects, and we put things into that container, we are copying them. The copy constructor gets called. Okay, so this last point is a really important one. When you create an object and you put the object into a container, okay, it's not actually like real life that I have, okay, I've got my phone here, I've got a container here, I put my phone into the container, okay? It's not like that. When I get an object and I put it into a container in C++, I'm actually creating a copy of this thing and putting a copy inside the container. Okay? So the copy constructor is being called at that point. So it's important to get the copy constructor right. Again, if you don't provide one, there's one provided automatically for you. Okay? And what it does is it just copies all the data members. Okay? This is fine if you're not using pointers. Generally fine if you're not using pointers. Again, on the tutorials next week, I've deliberately got an example whereabouts it's not fine, and you've got to find your own one. Okay? The copy is in declaration order. Okay? It's the same order in which the things were declared in a class. Okay? If there's an array, okay, the members of that array are copied by calling the copy on each element inside that array. Okay? So if there's some sort of container, copying the container, the elements inside that thing get copied, okay? But be aware there is a difference between shadow copies and deep copies, okay? You should already know this at this point, the difference between shadow copy and deep copy on some sort of container. Be aware of what goes on at this point, and again, that will depend on if you're using pointers and dynamic memory or not, okay? So for our sales data object, if we don't provide a copy constructor, by default, it looks like this. Copies the book number, okay, book name that should be. It copies the units sold and it copies the revenue, and the body of that constructor does nothing. That's the default one if you don't provide it. You won't see this code. The compiler just generates that code automatically for you if you don't provide it. Okay? This slide here might take some time to understand. This is another one of these quiz type slides. I have a class called myString. MyString contains a string, okay? It's just a wrapper around a string. Okay? I have two constructors. I have a constructor that takes in a char star, okay? Takes in a char star, and using uniform initialization, okay? It converts that char star into a string. Okay, so it converts the C-style string into a C++ style string. Okay, so the constructor does that. I then have a copy constructor that copies the data in one myString class into a second myString class. Okay. I then go into int main. Int main, myString S1, speech marks, ABC speech marks. Okay, this is a char star. Okay, so the first constructor gets called. The second line. Okay, so guy in red. Sorry, right off the back. I don't know your name. Hi. This is very similar to a question that you were asking before about the ints. Okay, when we were talking about int I, and you said, oh, can't we just make it equal to the thing? Okay, it's actually meaning something different in terms of what's going on. Okay. So this line 13 is copy initialization. What's happening? It's this ABC, okay, is being created to a temporary variable, okay? So the first constructor is being called, it's creating a temporary variable you don't know the name of, and then the second constructor is being called and copied across, okay? So the top line calls the top constructor. The second line calls the top constructor to construct a temporary object, then copies the temporary object across using the copy constructor into there. Okay, so that second line is slower than the first because two things are going on. Okay? but, you don't need to worry about this too much because the compiler will optimize most of these things out. Okay? So that's the saving grace there. Okay? Don't panic about that too much, okay? Because the optimizer will realize what you're doing and will make it faster and clear it up for you, okay? But you should be able to understand there's a whole difference going on at the low level here. Okay, so do we understand how that is behaving, even if that's not strictly what the compiler will do? Okay, we clear about this? Okay. So, again, just remember there's two different types of things here, okay? Because this next slide we're going to come back to what we looked at on Monday. On Monday we looked at this vector. And we looked at these explicit type conversions. Okay? And this is the case of where you can't put the stuff on the right-hand side. So we've got a standard vector, and we're going to give it a default size of 10. Doing it that way is fine, and again, those bracing should be updated with uniform initialization bracing. Okay? The next line, we can't say standard vector v equals 10 because that vector constructor was set to be explicit. We talked about this on Monday. If you've forgotten, go back and take a look at the lecture recording from Monday. Okay? So the copy initialization cannot happen on the standard vector. Okay? And the same thing if we're doing function calls like that, it won't work. Okay? So be aware that we've got this thing called copy initialization. There's problems that can occur on it depending on whether or not our constructors are declared as explicit or not. Okay? So to go back to the previous slide, the reason why this doesn't work, say if this constructor was declared explicit, is simply because we can't do that conversion to the string the same as what we can if we do it this top way. Okay? So be aware of these things. Okay? So this is why, hi, I'm just going to keep on picking on you, but for guy with a red shirt, this is why you shouldn't be doing the equals. Okay? It does mean something else. Okay? You could try, but you could try. I could literally have a go, see what happens. Okay, if you wrap it in braces as well after the equals, but your code starts to get quite confusing at that point. Okay? Okay, so we've talked about construction. We talked about initialization. Now we're going to talk about assignment. Okay? I've got two examples up on this set of slides here. The first example says my class 1 semicolon. Construct a variable of my class. The second line says my class 2 is equal to 1. This is copy initialization, which is what we've just been talking about over the previous couple of slides, okay? So what happens is the copy constructor gets called. Because we said my class at this point, the copy constructor gets called. However, next line down, my class 1, my class 2. My class 1 is constructed, my class 2 is constructed. I've got two objects at this point. If I say 2 equals 1, the copy constructor is not called. A thing that we're about to move on to is the copy assignment operator gets called. So that my class being there and not being there, these two lines of code mean very different things. Okay? So when a variable is created, it's created to hold a specific value. And it gets initialized at that point. When an existing variable, okay, so this is in the second line, when an existing variable is set to hold a new value, it gets assigned. So there's a big difference between initialization and assignment. Okay? So we talked about initialization up until this point. Now we're talking about assignment. So we have a thing called the copy assignment operator. And this is not a constructor. Okay, so the copy assignment operator is not a constructor. Okay, it's a member function. It takes only one argument, and like the copy constructor, it's of the same type, okay? So in my code up on here, it says sales data ampersand. Okay, so it's a function that returns a reference to a sales data object. Operator equals. Okay, as your first look at operator overloading, again, we're going to spend a lot of time looking over this next week. Okay, takes in a reference to a sales data object. Okay? What this means is because it returns a reference to the left-hand operator, okay, it behaves the same as a built-in type. So we can say ABC, and we can say A equals B equals C, like that, semicolon. In the same way, we can say I equals J equals K. Okay, we can chain these things together like that. Okay? And we use it just by saying equals. We don't say x1 dot operator equals x2. We just say equals, okay? Very different to if you've come from Java. In Java, you can't do this. Okay? We are now defining our own rules for what equals means at this point. Okay? And again, if we don't provide one, the compiler provides one of these things automatically for us. So the big five, the destructor, the copy constructor, the copy assignment operator, the move constructor, the move assignment operator. If we don't write them ourselves, the compiler automatically generates them for us and often does the wrong thing. Okay? So, if we don't provide one, what does it do? It copies the data from this right-hand side across into the values, placing the values inside our class that we're copying into. Okay? So very similar to the copy constructor in terms of it copies things, okay? But behavior is slightly different. The right-hand side is copied into and replacing the existing values on the left-hand side. Okay, so this is replacing existing values. It's not initializing like what we had before. Okay? So we're clear about this at this point. We're clear about we've got construction and we've got initialization and we've got assignment. Construction does initialization. Assignment replaces values. Okay? We're going to come back to this next week, okay? But I've got 2 more slides to go. So how do we prevent copy? Say if we wanted a class you simply can't copy things for. Well, you can delete functions. So here's a class called noCopy. The default says generate the default version, okay? So the noCopy equals default just says to the compiler, go generate the default version of this thing. The delete tells the compiler, do not generate your own versions of these things, your own compiler versions of these things, delete it. I don't want this thing at all. Okay? So this class, this noCopy class, cannot be copied. Okay? I don't have a good example where you'd use this, okay? Maybe I'll think about one over the weekend, okay? But you can delete functions like this, okay? Oh, here's a good example. So with the IO types, okay? With IO types, we can do this. We cannot pass cout into our print function, okay? But we can pass a reference to it, okay? So you might want to force something to be passed by reference rather than passed by value, okay? Also be aware, do not delete the destructor, because if you delete the destructor, objects can only be created and never be freed. Do not delete your destructor, okay? And on that note, to be continued. Okay, so we're going to pick this up next week. Okay, thanks.